All right, last one. And TVM solver. Love to see it. So remember, with TVM solver, there's two types of questions. One is compound interest. And that essentially means there's no payments. And in those cases, P over Y is just equal to 1. The second type is called an annuity, and that means that there are payments. The only other thing you really have to remember is the direction of money. A lot of the time, it won't really matter. But in some cases, it can. So money that is coming to you and money that you are investing or repaying, they go in different directions. They have to have different signs, right? So one positive, one negative to show which direction. There's no hard and fast rule. I like money that comes to me as positive, which makes me happy, so it gets a plus. Money that goes away from me makes me sad, so it gets a minus. So let's go. Daria wants to save enough to have $25,000 in 5 years to help pay for her graduate studies. She found an investment that earns 4.5% compounded quarterly. How much does she need to invest today to reach this goal? So invest today. There's nothing about payments. So there's nothing about things happening every month or every week or every year or anything. It's just money today gives us money in 5 years. So this is a compound interest problem. So payment is 0, P over Y is 1. Easy peasy. So she wants to have $25,000 in 5 years. So that's in the future. It compounds quarterly at 4.5%. We're trying to solve for PV. And then N is the number of payment periods, which is the number of years. Ooh, that's a weird shape. Okay. The number of years times P over Y. But for if it's not an annuity, P over Y is just 1. So it's just the number of years, which is 5. So we'll go get our finance calculator. We are solving for PV. How much do we need right now? 5 payment periods, 4.5%. Periodic payments is 0. Future value, we want $25,000. And we got to press plus to get in here. Payments per year is 1. Compounding per year is 4 because it compounds quarterly. We'll calculate, and she would need to invest almost $20,000, $19,988. So PV equals $19,998. So that's how much they would have to invest today. And it's negative, but that's okay. Negative just means that it's going the opposite direction of the 25,000. 25,000 is coming to us. It's positive. The 19,998 we are putting into the bank. It's moving away from us, so it's negative. That's all that means. Terrence deposited $6,000 in a savings account 10 years ago. Today the account is worth $11,000 and some change. The interest compounded monthly. What is the annual interest rate? So again, nothing about payments, nothing happening over and over and over again. So this is compound interest. Payment is 0, P over Y is 1. They deposited $6,000. So our P over PV would be 6,000, and it was deposited. It went away, so it's a negative. Today, if they took the money out, it would be worth $11,615.20. And you'll know I didn't write a comma. Sometimes that can mess up some of the calculators. I guess it didn't last time. Okay, it's compounded monthly, so that's 12 times per year over a 10-year period, and we're solving for the annual interest rate. We want interest rate, 10 payment periods, -$6,000 goes up to $11,615.20. 12 compounding periods. So we would need an interest rate of 6.624%. So I over y equals 6.624%. And I'd like your answers written over here, not here, because then I can't really tell exactly what you're doing quite as nicely. So, but yeah, if we didn't do that direction of money, we would get a much different value. And in this case, it wouldn't even work. So if you're getting errors, that's a good possible reason where that error is coming from. Next, Annalie has decided to invest $250 bi-weekly. So she's doing it over and over and over again. That is a payment. And since it's being invested, it's going away from her. So it's happening bi-weekly, which means every 2 weeks, which is 26 times per year for 8 years. We'll deal with that at the end. The interest rate is 4.8%, compounded monthly. So she's starting with nothing. We're finding how much she has at the end. And N is 8 years times 26 times each year, that P over Y. So that's really important. 160 and 48. 208. Make sure I did that right. All right. We go to our calculator. We are solving for future value. 208 periods, 4.8%. 0 for present value, -250. 26 periods per year. Ooh, I didn't check. Did I check? Compounded monthly. All right. We hit calculate. We have $63,310.51. Future value equals $63,310.51. Amelie wants to save $75,000, so that's what they want at the end. $75,000 to use as a down payment for a house. Oh, he plans to deposit $1,200 monthly, so that's payment. $1,200 every month, 12 times a year, into an account that earns 4.2%, compounded monthly. You see monthly a lot. How many years will it take him to reach his goal? So he's not starting with anything. And we can't just directly solve for years, but we can solve for N, the number of payment periods, and then figure it out from there. So this time we're solving for N. 4.2%, 0 present value, $1,200 per month. We want 75,000. Payments and compounding is both monthly, so we get 56.62. N is equal to 56.62, but 56.62 what? Is it years? Well, we have to look. What are our periods? Our periods are 12 per year, monthly. That means this is months. So I have to take 56.62 and divide it by 12 months in a year to get how many years it will take. And we get 4.7 years, roughly. Aisha wants to buy her first car. She can afford to make monthly payments of $560. So she's paying $560 per month. So that's our payment, and our payment periods per year is 12 because it's monthly. It's taking out a loan, right? Usually when you buy a car, you borrow money and then you pay it off every month. So if the loan has an interest rate of 5.99%, whoops, we don't write the percent, compounded monthly, what's the maximum amount she can borrow? Oh, 6 years. Whoops. I'm thinking that's 6 years. So n is 6 years times 12 months is 72 total periods. And then we just have to figure out, are we solving for PV or are we solving for FV? Well, it's a loan. So loan means you're going to get the money at the start, and then you're going to pay it back, and then at the end, you don't owe any more. So that's how that's going to look. We'll bring that over. We are solving for present value. 72 payments, 5.99%, $560 we're paying every month. We're not going to owe anything when we're done. Monthly still. So $33,799.75 is how expensive of a car she can buy. It doesn't mean it's a good idea to use all of it, but that's her budget. That's the maximum she can afford. Last one, Doris is planning her retirement. During retirement, she thinks she will need $4,000 of income every month. So that's a payment coming to her. $4,000 every month. So it's positive. It's coming to her. She thinks she's going to live 25 years. So it's $4,000 every month. My P over Y is 12. So it's 25 times 12, which is 300 payments she'll need. She currently has $1,012,000. So that's present value, $1,012,000. She thinks she'll earn about 4% in retirement, which makes sense. Compounded monthly with another typo. Wow, great. Does she have enough money to retire? Well, what do we do here? Are we solving for FV? Well, no, we're thinking she wants to start with this money and end with nothing, so that's nothing. So we have the whole table filled in. So how do we check if she has enough money to retire? Well, we can solve for any of these values, right? And see if there's enough. We could solve for FV and see what happens at the end, but there is one mistake here that I hope you caught while we were going. She has $1 million, but she's going to be investing that in order to draw income. So yeah, let's try solving for FV. You can solve for FV, you can solve for any of them. You can just pretend you don't know one of them, solve for it, and see if it works. If it works, then she's golden. If it doesn't, then there's a problem somewhere, and it'll tell you the best she could actually do. So one option is we could just solve for FV. Minus 1,012,000. $4,000 payments monthly. And what would that calculate to? So that says our future value is still $689,000, meaning that we've still got money to spare, which is great. We've made almost $900,000 in interest in that 20 years. So that's great. She's in really, really good shape. So you could say the calculated FV is $689,812.15, meaning she will have enough with plenty to spare. Another option is we could see, does she have enough money? So we'll calculate how much she would need. So if she was going to take $4,000 a month for 300 months. Oh, is that the mistake I made? 25 times 12. 25 times 12. That's 300. All right. Yeah, 300 months. Okay. It seems like there's a lot left. And we can calculate how much she would actually need. And she would need about 760,000. And she has over $1 million. So she's good. And this is a little more simple. It doesn't account for taxes and everything else. But there's lots of different parts you could check to see whether it works or not. All right. Tiny bit left and we're done. Exponent laws. So -6 times -6 to the power of 5. So we got to remember, if it doesn't say, it has an exponent of 1. And then we're going to use our exponent laws. So exponent laws say if two powers have the same base and they're multiplying, we just add the exponents. So that is -6 to the power of 1 plus 5 is to the power of 6. Easy peasy. B, we have our power rule. This is a power to a power. So power to a power rule says we take our base and then we multiply the exponents. So 2 times 4 is 8. Here's our, so we've had product rule for A, power of a power rule for B, and then we have quotient rule for C. When we're dividing powers with the same base, we subtract the exponents. So this is just 9 to the power of 7 minus 5 is 2. And we could write that out as 81 if we wanted to. D, quotient rule again. We do the subtraction, because this means 26 to the power of 6 divided by 26 to the power of 5, right? So we get 26 to the power of 1, or just 26. Now, when we've got fractions, exponents apply to the numerators and denominators. But let's do our product rule first. So we have two bases that are the same, 3/4, 3/4. So we can add the exponents. 3 over 4 to the 7. And then it applies to each individually. 3 to the power of 7 over 4 to the power of 7. And you can work that out, or you can leave it like that if I don't say evaluate. If I say evaluate, do the calculation. If I say simplify, you can leave it like that. Here we have power of a power again, so we just multiply the exponents. 4 to the power of 3 times 5 is 4 to the power of 15. And we're done. That's it. You did all the review. You are super prepared. I hope your cheat sheets are in order. I hope this was helpful, and best of luck on your exam.